on the track. We'll begin with a look at a modern work gang and their amazing parade of track machines. Timber and Surface Gang Number 1, Norfolk Southern's elite corps of highly experienced engineering and maintenance of way employees, is working across southern Illinois. These men are dedicated, fast, and excellent at what they do. They take pride in knowing that they are the company's best outfit. The gang's job is to replace worn ties and then to resurface the line. This means to tamp ballast under the ties to lift the track level and to smooth out the alignment. To finish the job, ballast is groomed into the classic look of a high-speed mainline to aid in draining water away from the ties. New cross ties have already been dumped along the line, and the first piece of equipment to lead the procession of machines is a tie crane. The crane operator positions ties near the location where an old one will be removed. The joystick controls respond to every movement, and the machine seems to become one with the skilled operator. Extra ties are placed on one of the carts. At a point down the line, these ties may be needed at spots where too few have been dropped. Following right behind the tie crane are 4 spike pullers. These little machines pull spikes from the ties that are going to be replaced. Each machine pulls spikes from just one side of the track, but works both the inside and outside of that rail. The first 2 spike pullers will work a section and then leapfrog ahead to another section. The trailing 2 machines will work the section passed over by the first 2 pullers. Hydraulics make a quick job of actually pulling a spike, but the operator must be skilled in placing the jaws of the puller directly over the desired spike. This is a task that often requires several attempts. Sometimes an operator gets in a groove and pulls several spikes without a problem. The little machines move right along, and in a good day, a T&S gang can cover several miles. The removed spikes are dropped on the ballast and will be picked up by another machine, the spike loader. Here we see the strange-looking critter as it progresses along the line. Empty spike cans are stored on racks along the side of the machine. 4 large magnetic wheels pick up the spikes. A pair of wheels runs alongside each rail. At the top of each wheel, the spikes are forced off into a bin. From there, they ride into a rotating drum, which cleans the spikes by knocking off dirt and debris. From there, they are carried on a conveyor belt to the rear of the machine, where they are loaded into empty spike cans. Once a can is loaded, the operator uses the onboard crane to lift the can onto the back of the cart. The railroads today make a special effort to clean up all material and litter from a work site. Nothing will be tossed into the weeds or over a hill in today's world. The process continues with the arrival of the anchor spreading machines. The anchors are clips that hold rail longitudinally in place. A hydraulic press on this machine spreads the anchors apart to make removing the tie plates possible. A close-up shows the anchor spreader at work, but it's difficult to actually see what is happening. The end result shows the anchor located several inches away from the tie and tie plates. 2 of these machines work together much like the spike pullers. Each machine has hydraulic presses that work the inside and outside of each anchor on both rails at the same time. A look down the line shows the next sequence of events that will take place. A tie removal machine is busy pulling out the old ties that will be replaced. Behind that are 2 tie cranes that are picking up the removed ties, followed by another crane placing new ties at the exact spot for the insertion machine. The tie puller latches onto and then lifts the rail to permit ties to be easily pulled from under the rails. The end of the puller grasps the ties as the arm of the machine drags them to the side of the roadbed. The entire operation is usually handled in just one movement, but occasionally a difficult tie forces several attempts to get it away from the rails. Behind the tie puller, a couple of men on the ground use long hooks to move the tie plates out of the way. The plates will be reused after the new ties are installed. A crane operator's job requires a high level of skill to work fast, picking up the old ties and placing them onto dump carts. Speed is an important part of the gang's overall objective, to cover as much ground as possible each day. Notice how these guys are hustling to keep working at a steady pace. You won't find these guys goofing off on the job. They know they won't be around long if they can't keep pace with the rest of the crew. A tie with a bow in it gives the operator a bit of a challenge to get it stacked on the cart. Once 16 ties have been gathered, the man on the ground bands them with metal strapping. A spot is found where the bundle can be dumped without being in the way of the other machines. The cart is outfitted with a side dump platform, and the ties are shoved onto the ground. Rest assured that they won't be left here, however, as they will be picked up before the crew leaves the area. The man doing the banding goes about his task as the tie crane moves down the line to keep pace with the other equipment. Another tie crane follows, and its job is to place a new tie into position up against the rail for the tie insertion machine. Extra ties are carried along just in case the earlier operator missed a spot. Again, note the skill required as the ties are placed in specific spots while the crane continues moving along the track. We speculate that these crane operators are pretty good at handling a computer game joystick. When the machines get bunched up, it makes for a neat-looking sight as they go about their tasks. Two tie insertion machines work like the other paired machines and leapfrog over a section while working the next part of the line. These machines are near replicas of the tie removing machine with one exception. Note that they do not lift the rail before inserting a tie. The powerful machine simply jams the tie under the rail to make a snug fit. A track broom follows to clean ballast from the newly inserted ties. It's necessary to keep rock off the ties so it won't get in the way when the tie plates are reinserted under the rail. Rotating rubber brushes under the machine kick the rock off the ties, but also kick up clouds of dust. A man walking behind the broom controls the machine when necessary, but once a pace is set, the machine requires little attention. His primary task is to place tie plates into position for the insertion gang. He uses a hook to help with the task and handles just one side of the track. Another man will do the other side ahead of the insertion machine. Now, don't expect anything too elaborate of the plate insertion machine. It's mostly another manual task. The machine is there to lift the rail, but the plates are manually positioned by the two men. The machine grasps the rail, and then jacks located on the bottom of the machine shove down on the tie. This action lifts the rail so the plates can be inserted. Again, hooks are used to handle the plates to save on back bending and fingers that might get smashed in the process. The trick here is to not get one's toe caught under the rail. With new ties and tie plates installed, the next job is to spike everything down. Two automated spike drivers handle the task. Again, this is one of the jobs that requires a great deal of skill to line the spike up with the hole in the tie plate. One man rides on each side of the spiker and is responsible for his side of the track. One spike is placed on each side of each rail on tangent track. On curves of more than 2 degrees, 4 spikes would be used. On severe curvature, heavier plates and spikes would be installed to hold the rail in place. The spike crew has stopped to reload. The procedure is much like loading a staple gun, but on a much larger scale. Once full, the spikes are lined up in their racks, and the crew is ready to go back to work. Following the two automated spiking machines is a manual spike driver. The two men assigned to this machine check the line for missed spikes and ones that are defective or not driven in all the way. Two more men on the ground walk behind the manual spikers to replace missing anchors on the rail. They simply place an anchor but don't have the equipment on their machine to press them onto the rail. This is done by another machine that comes along next. It uses a hydraulic press to squeeze the anchors around the bottom of the rail. Once this group has finished their work, the track is ready to be resurfaced. We'll return to this same location the next day to cover the operation of those machines. When a track gang on Norfolk Southern goes out to work in the field, they go as a fully self-contained operation that resembles a military campaign. The men eat, sleep, shower, and watch TV or relax in specially equipped truck trailers. This is the kitchen trailer, where all of the meals are prepared by a full-time staff. One of the cooks is preparing soup for the evening meal and pulls flavor pouches from the steaming stock pots. The men eat well on these work gangs too. This pile of thawing steaks will be for the evening meal. Next to the kitchen is one of the trailers housing a dining hall. The next morning we pick up where we left off and watch as a ballast regulator works the line. This regulator is piling ballast onto the track for the tampers. 4 tampers will work the line to squeeze ballast under the track, lifting the level of the line 2 inches on tangent track. The purpose of this operation is to smooth the surface and to correct any misalignment. The box atop the end of this tamper sends a high-intensity beam of light back to photocell receivers on the main portion of the tamper. This tells the machine operator how much lift has been applied to the track level as it works the line. While the tamper continues working, a westbound freight comes past the site. It's fortunate for the crew and the track gang that they are working along a passing track. Otherwise, either the train crew would be held up, or the track gang would have to get in a hole somewhere to clear up. A necessary time waster for all involved. The tamper sticks its vibrating tongs into the ballast and squeezes the rock up under the ties. As it does this, the tamper also grabs onto the rail and lifts it up. These devices that look like lights are the photocell receivers for the high-intensity lights. The end of the freight passes as the parade of tampers and regulators continues to work. The trailing ballast regulator has the job of dressing the line. The last two tampers are smaller versions of the larger ones that do not operate with light control. Note that the second of the large tampers is working on just every third time, and that it is not lifting the rail as it tamps. The first of the two smaller tampers is also doing every third time, and as you can see, doesn't operate with the light-sensitive measuring equipment. The fourth tamper is only used to make corrections to skewed ties, and therefore does not always have work. Behind this tamper is a man who checks for any further problems with spikes or anchors. When he finds a spike that's not been driven in all the way, he has to resort to manual labor to drive it. Now this is a task that takes us back to the earlier days of railroading. A machine called an anchor masher follows the last tamper. Its job is to squeeze the anchor snug against the tie plates. A ballast regulator now comes into view and piles a large amount of ballast up along the track. The machine will make several trips back and forth to groom the ballast into the desired shape for proper drainage. The machine now backs up to make another pass. It will take several passes to complete the job, and the regulator will therefore work over a small section of the track at a time until the job is done. In the meantime, the man on the anchor masher has found a rock trapped by an anchor and forces it out with a tool. Next pass by the regulator finds it piling a little more rock on the rail and grooming the lower part of the ditch. On the next pass, the regulator has lowered its plow blades to clear a portion of the rock out from between the rails. This time, it will use the front blade as a wedge plow to get more rock off the track and shift more ballast over to the south side of the line. Coming forward again, the blades have been adjusted to keep plowing rock to the south side. Reversing once more, the rock continues to be shoved to the south side of the line. Now coming forward, the blades have been formed into a wedge to evenly place rock on both sides of the rail. The side blades smooth out some of the lumps along this side. This just about does it for moving ballast. And now the unit brooms the rock as it backs up. One more pass with the broom as the regulator comes forward for the last time leaves the track looking pretty darn good. However, 2 more brooms will complete the job by making the line look well groomed with all rock in its proper place. This set of brooms has no operator on board, but is controlled by a man on the ground. Each broom has a specific purpose. The first kicks out most of the rock from between the rails. The second broom plows a channel of ballast from the end of the ties and cleans the portion of the ties outside the rail. Once the dust has settled, we get a view of the freshly resurfaced line. Looks pretty good, and it's now ready for some high-speed running. Just one more task remains to complete this job, and that's to remove those piles of bundled ties. A specially outfitted high-rail truck with a crane and pulling a trailer now arrives to collect those old ties. The operator swings the boom around and signals the driver to pull ahead to the next bundle. The forks latch onto the next 16 ties, and they're lifted aboard the trailer to conclude our look at the operations of a timber and surfacing gang. Deep in the heart of Norfolk Southern coal country in southwestern West Virginia, we watch as a train of empty hoppers is hauled up a branch toward a mine. These gray-colored hoppers, called top guns, have become quite familiar in recent years to observers in the eastern part of the country. Norfolk Southern undertook a major program and rebuilt a total of 17,052 of these hoppers from older cars like these seen on the rear of the train. The cars were rebuilt here at Norfolk Southern shops in Roanoke, Virginia. Top Gun 31103 rolls out of the paint shop after having just been constructed. 6 hours earlier, the car was nothing but a bunch of parts waiting to be assembled and welded into a modern coal hopper. As you can see from the date on the side of the car, we visited the shops during July of 1995. We'll be touring the entire assembly line to see how these cars are put together. Every day, Monday through Friday, approximately 10 cars like this roll off the line and out the doors of the paint shop to join Norfolk Southern's growing fleet of Top Guns. The old cars are completely stripped down to just the center beam and bolsters at another location in Roanoke and then hauled to the assembly shop. Reusable parts such as brake valves are sent to other shops to be rebuilt and then returned here. Trucks are also rebuilt. Some cars are so deteriorated that even new center beams need to be built. All parts are identified with the car's serial numbers. Before the assembly line begins to move, warning sirens sound to alert the workers. The line moves forward one car. The process starts at the end of the line and works back here to the start. The first stop is where cars are prepped to go onto the line. Rough edges are ground smooth, and if any holes need to be placed in the center beam, a plasma arc cutting torch is used for the job. The center sills will be removed from their trucks and ride on these shop bogies along the assembly line. Inside the shop building, the first station prepares the male center casting. New metal is added where it was worn to bring it back into specifications. The coupler pockets are prepared and new angle iron is attached to the center sill. These braces will help support the floor and sides of the car. You can see that we are about 3 stations down the line now, and the car is ready to have the bottom attached. An overhead crane lifts the chassis over to the station where this will happen. After the floor has been welded in place, the car is lifted once again over to the next station. Here is where the end pieces will be attached. Once the car is ready, the overhead crane delivers one prefabricated end at a time and slowly lowers it into position. The workers pound and wrench the pieces into their respective slots, where they will be riveted together. Welding will take place at another station. Once both end pieces are attached, the car is lifted back to the line and placed on shop bogies again. The line moves forward, and at the next station, the car will have welds required up to this point completed. Offline, we see side panels being built as they come through a giant press. A couple of men work with massive drills, boring holes at specific locations in the panels. Welders begin the task of sealing all the seams on the car. On the other side of the building, more welding is being done on almost completed cars near the end of the assembly line. Major welding gets underway now to attach inside bracing before the sides are brought over. The electric arc welders are wire-fed, meaning that a continuous feed of welding rod is automatically fed to the tip of the welder. This makes the job go much faster, since the welder won't have to stop work to pick up another rod. At the far end of the building, a crane has just picked up a side panel and is headed this way with it. The crane lifts the panel up high to clear the rigging of this work bay, where the panels will be attached to the car. The sides are slowly lowered into position, and a worker guides the panel to just the right spot. A rivet is quickly placed in a pre-drilled hole to help hold the panel in place. At the end of this portion of the line, cars are pushed onto a transfer table and moved to the return portion of the line. The cars now have the final shape of a coal hopper, and on this line they will have the rest of the welding done and all of the appliances added, such as air lines, brake valves, reservoirs, ladders, grab irons, hoses, and so forth. We've relocated now to the end of the line. The car in the background is having the final welds done. After the next station, the cars are picked up by a crane and moved offline to the next to last station before the paint shop. Here, couplers and air hoses are added, and we watch as a coupler has just been placed on this car. All that remains is to place the completed car on its trucks now. The rebuilt trucks are rolled onto the shop floor and must be turned to line them up with the shop tracks. One at a time, a winch pulls the trucks onto a miniature table where they will be turned. The second truck is turned, and then the pair are chained together, and another winch pulls them ahead to the final station in the shop building. Soon, the overhead crane lifts the newly constructed car body out of one bay and onto the trucks. Some final adjustments will be made once the body is in place, and several more items will be completed before the car is ready to enter the paint shop. Once everything is complete, the winch cable is attached to the car, and for the very first time it rolls under its own trucks as it heads for the paint shop. The car is painted gray in an automated process that is impossible to shoot due to the way the paint is applied and the environmental recovery system in the downdraft water wash spray booth. The special paint does not require the bare metal to be primed. Once the car comes out of that bay, it's ready to be stenciled, and the Norfolk Southern logo is painted onto the side panels. The big stencils are removed by a small overhead lift, and then the car number is painted using handheld stencils. All of the other information seen painted on car sides is added to complete the job, and car number 31101 is now done. In a couple of days, it'll be in the coal fields, earning revenue for the railroad. During the summer of 1998, Burlington Northern Santa Fe undertook a major construction project to rebuild its Thayer subdivision in Arkansas and Missouri. The busy line was completely shut down for 2 weeks during what the railroad called the Blitz. One of the project goals was to undercut approximately 40 miles of track. Undercutting is exactly what this massive machine is doing. As it slowly moves up the line, dirt and debris are removed from the ballast and discarded to the side of the track. How this material is extracted from underneath the cross ties is the really neat thing about an undercutting machine. Scoops located on each side of the undercutter collect material and transport it into a vibrator which separates the ballast from dirt and debris. The material is removed from under the track by a mechanism that resembles a large chainsaw blade. Large teeth rotate on a band that is suspended under the track. As the teeth whirl around, they kick out the ballast and debris for the scoops to collect. A metal wheel on the machine lifts the track while the undercutter blades are moved along underneath the ties. The view from behind the scoop shows concrete ties suspended in the air as the track is coming back to rest on the ground. It's nearly impossible to see any part of the actual undercutter blade while the machine is working. Notice the different level of the track before and after the dirt has been removed. Fresh ballast will be dumped on the line after undercutting is complete, and then the line will be tamped and regulated to complete the job. The vibrator separates good ballast from the dirt and debris, and then the junk is moved by conveyor belt off to the side. On this particular portion of the line, there is not much ballast left. This is one of the reasons the line needed to be rebuilt. Inside the climate-controlled cab, the machine operator adjusts controls and constantly checks on the machine's performance to ensure that the job is being done correctly. We'll take a moment to just watch as the machine continues to work up the line. This unit is an impressive machine, but not the largest of undercutters. Take a look at this one, which is also operating on the Thayer Blitz. This machine is actually a series of machines working together. The first section is cleaning ballast from along the sides of the track, but is not undercutting. The second section is an undercutter and is working just like the smaller version. Plows along each side of the first section move ballast into the center of the track, where it's picked up and moved into trailing vibrator cars. The material is moved from one car to the next on a series of belts, and the debris is later dumped trackside from the boom conveyor. The second section of this massive machine is where the actual undercutter is located. It functions exactly like the smaller machine, with the rotating blades moving material out from under the track and the side scoops collecting and transporting it into another vibrator. Here we see the track being lifted out of the ballast as the undercutter blade approaches. A major difference on this portion of the Thayer sub is that there is actually plenty of real ballast here, instead of mostly debris like at the other location. Like the other machine, this one also has a climate-controlled operator's cab suspended above the action to monitor the operation. Having a lot more ballast to work with in the first place, much more of the material is being returned to the track instead of being discarded. What we're seeing here is the back side of the undercutter blade under the track. Since the teeth are moving at a high rate of speed, it's difficult to actually see them. However, if you look very closely at the bottom of the blade, you can detect rapid boring movement. The housing around the teeth prevents us from being able to see more of the action. Once the machine is stopped for maintenance, we finally get a view of the rotating teeth and can actually see what they look like. They run around the oval-shaped guide, similar to the way a chainsaw operates. Although a fair amount of debris is being discarded, it's nowhere near the amount that was being removed from the other portion of the line. Behind the undercutter, 4 track machines groom and tamp the cleaned ballast to reshape the roadbed. A large ballast regulator comes first, and the big unit appears to be of European origin. It's those large bumpers on the front that make it look like an imported machine. Behind the ballast regulator are 2 different tampers. The first is outfitted with a high-intensity light system to guide the leveling and alignment of the track. Behind it is a smaller-sized tamper. Bringing up the rear of the fleet is another ballast regulator. This one has the job of grooming the ballast into that neat mainline appearance that helps drain moisture away from the track. Years ago, trains ran by timetable and orders. Until fairly recent times, this was still the rule in Mexico, where these scenes were obtained in 1990. Telegraph messages were transmitted up and down the line to notify station operators when it was necessary to type Form 31 orders for a train. To communicate with the crews, stations used order boards to notify approaching trains if they had to stop or slow for new orders, or if it was okay to proceed. Today, that has all changed, and modern dispatching centers like this now control the flow of traffic across high-density lines. We're visiting the dispatch center of Norfolk Southern's Pocahontas Division at Bluefield, West Virginia. The big board running the length of the room reflects all of the track within the division that's controlled by centralized traffic control. In a glassed-in room behind the dispatchers is where you'll find Chief Dispatcher Tommy Johnson. He's a busy man, but in just a few minutes, he'll be able to give us a rundown on what happens here.
And that's Chief Johnson.
Hey, Tommy, this is Jerry. I just want to...
The chief is a crisis prevention coordinator who keeps the division fluid. Let's listen as he handles some typical issues before they become problems.
The next train through is going to be, well, you got that grain train I'm telling you about. It's got 49 Norfolk grain, 131 Tidewater. And then behind him, you got the dust train. And then behind him, you got an 820 off the Clinch Valley. He's going to have 130. Now, I don't see another Tidewater train behind him till I'm coming out of Allville with the rest of that 5061M. I'm going to bring it up here and set it off at Bluestone, then go back to Wilco and get those Katy, come back up and fill out. I'm not sure how many that's going to leave. I'm going to have to do some figuring where I can tell how many that's going to leave me short. Hey, Rick.
Sir.
How big's 129 going to be east of Canova?
We can't see anything on that 129 yet. We got 129 computer yet. That's haven't got it drawn up yet. They added one car at Columbus, and they haven't got it in the computer yet, Tommy. Can I call you right back?
Yeah.
Okay, I'll try to see what it comes out and call you right back.
I need to know if I need a pusher for him.
Okay, I'll let you know here in just a minute.
Okay.
Hello.
This 148's got to stop there at Yeager and turn his lead unit.
Okay.
He's low on lube oil, and I'm afraid he's going to lose it before he gets to Bluefield. So when he turns his unit, we get his pusher on. Have him keep that lead unit isolated till he gets up here on Elkhorn Mountain.
All right, hang on 1 second.
Okay.
All right.
238.
Hello. Yes.
Basic overview of the board so you understand what the operation is. All the black lines are indicate the signaled track. That represents about half the track on Pocahontas division, and that's what's signaled. The rest of it is branch lines that go up to mines that it's not signaled. Each name with the number under, that's a control point where the signals and switches are controlled from. And the dispatcher has one keyboard that's dedicated to that function. So what they do, if they want to request a signal or a switch at a certain location, then they'll call that location up on their keyboard. It will light up white, and they can ask for a signal or a switch, and then they have the ability to cascade ahead as far down as they want to go. The red indicates, the red lights on the board indicate the track is shunted, either by maintenance equipment or by a train. For example, up there at Elkhorn, there's a red light. It was in the tunnel. It's moved down. He has the little green light indicates that at Mayberry that the signal's lined for him and the route's lined for him all the way down to Big 4, where you see he's crossed over from Main 2 to Main 1 track. See the green light blinking?
Right.
All right, then there's a train ahead of him. There's a red block, so that green light will continue to blink until that train moves forward enough to allow that signal to come in. That's all handled through relays in the field. When you see these red control numbers blinking from time to time, what that is, when the dispatcher asks for a signal to be lined or switched or any field function to take place, it sends a request out to the relays in the field. The relays act on that request and then send an indication code back to the dispatcher, and each time that that's received and sent, those little red lights will blink. They'll blink again whenever something takes place that affects them. For example, if a train moves up to another block or the track is shunned for some reason and the signal is taken down or is knocked down the field, then you'll see a little red light flash, and that's sending an indication back to the dispatcher that area has had activity. The other thing that this computer does, he's got two, as you see, we call them train summary CRTs, and he does that because he has more than one page of trains. One's eastbound and one is westbound. It's divided in the middle. And when those red lights blink up there, they automatically track the trains, and it sends the control back to this CRT telling him that train went by Mayberry at whatever time it went by. So that helps him keep track of where the trains are. That basically explains the board, except, like I said, the blue blocks indicate track shunt or track protection for on-track equipment, men and machinery that are working on the track. That's an office function, and what it does is it prevents the dispatcher from requesting a signal into that section of track for the protection of the men that's working. The screens that he's working with, he's got, actually, there's 5 here. The far one is discontinued use since we went to standalone detectors. It used to feed information back here about what time a train went over a detector and what time, which direction it was and speed. Now that we have standalone detectors every 15 to 18 miles that speak to the trains themselves, that's no longer generated in here. The next two are his train summary screens, what he's working on right now, and that keep tracking the train and all the train information, and eventually provides a train sheet at the end of the day. The next tube here to his right handles his train clearing system for dispatcher bulletins. It's a MAMO system that they work with. It also contains the track warrant system for movement on dark territories. So that's what comes out of that, plus any mainframe application. The tube on his far right, it's got all the little squares as communication tube, and that's all the radios that are on his territory. If someone calls him up, codes up the radio, then it begins to blink, and then he just accesses its touch-sensitive screen. He has the 4 keyboards. The black one is for his signal and switch functions. The other one on top is for his mainframe and track warrant computer, and these other 2, each one are tied independently to a CRT. It's heavy on keyboard configuration. We're working on updating that now.
Just as soon as the Pokey sub-dispatcher finishes a job, he'll give us a rundown on everything that's happening across his territory between Bluefield and Glen Allen, a distance of 80 miles of high-density railroading.
Don't look good. I've got a crew over there now getting those loads out of Litwar, and has to pick up at Hull. And the carbo just by Crowlitz to go up the main. Yeah, we'll just have to take a few minutes. Oh yeah, it's all gonna be tied up there for a while. Yeah, but I've got a coal train right behind him. I'd like to go ahead and run him too, and he can be getting a pusher on while we're down there, while your U-19's out there making his move. As long as I got your support, that's all I need. Okay, at Allen Street, lined up west on Main 2, which is your top track, is a hopper train, Q59, going to Williamson, West Virginia. That is a yard crew working in the top track at Arch. And on Main 1, which is the bottom track, between Bluefield, Virginia and Allen Street, is the Burro crane working. And we get on down to Falls Mills, going west on Main 2. That is a pusher, 1-engine pusher, who's going west to meet up with the time freight that's coming east. Main 1 track, Bluestone to Crozier, is welders working in the crossovers at Mayberry. It's where it's red. And let's see, just by Mayberry, going west on the Main 2 track, that is a set of light engines going to Allville. And just by Powhatan is a pusher, which is also going down the road to meet up with another coal train. And let's see. Approaching Norfolk is a hopper train, the 857. That's 178 empties going to Allville. See, lining up here at Big 4 now to come east on Main 2 is a work train, who'll be working between Big 4 and Ekman on main 2 track. And just by him on main 1 going west is another hopper train. This one also dedicated to Bend Creek. And waiting at Hemp Hill on main 1 is a pusher to go west. And ahead of him at Farm is another pusher on main 2 track. Going west. Just by Caples on the main 2 track is a light crew 658 going to Allville, where he'll eventually die at Allville and taxi on to Williamson from there. In the middle track at Farm, waiting to come east is a 856 with 130 loads of coal. On main 1, which is bottom track, waiting to come east is Coal Train 564, 118 loads coming to Bluefield. That brings us all the way down to, next thing I've got going on is there at Allville. And there at Allville, crossing over, going east on Dry Fork main line, which is right here. Okay, this crew that's going east right there with the 4 signals flashing. That's a Q19 coal train, which is destined carbo. And let's see, cleared up on the east leg of the Y. That's a pusher I've got waiting to get on a coal train. Next thing we got is a crew here at Hull on the main 2 track. And he's pulling loads out of Litwar, which is where the switch is flashing there now, that little block there. He's going to pull loads out of there and pick up out of the middle track, which is here. He'll pick loads up out of that middle track there. Then he'll go on west to Williamson eventually. Next thing is coming by Panther, the 864, which is Coal Train 100 and, well, let's see, he's only got 73 cars. He'll be getting the pusher that we've got parked on the east leg of the Y there at Yeager. And he'll come on to Bluefield eventually. And going west on main 2 track there at Alt 1 is the 233, time freight going to Williamson. And that covers about all we've got except for the Gilbert Branch, which runs from Warrencliff to Ned's. And I've got a crew there between Bend Creek and Ned's that's working a mine called Skaggs. And that just about covers it. Y'all taxi to Allville again, get another train. Nope. All right, appreciate it. All right, we'll see.
Returning now to the Burlington Northern Santa Fe Thayer sub near the Arkansas-Missouri state line, we'll be taking a look at one of the most awesome pieces of track equipment ever built. It's the P811 concrete tie laying machine. Running several hundred yards ahead of this amazing contraption is this simple spike puller. Another spike puller is physically connected to the P811 machine, which we'll see later. By using this additional puller, it speeds up the overall operation of the tie laying crew. These guys will not remove every spike because the P811 is being pulled by a heavily laden train carrying all the concrete ties that will be used today, plus all the old wood ones that have been removed. The train is following the spike puller several hundred yards behind it. As the locomotives creep slowly around the distant curve, we get our first look at the old ties piled on specially equipped flat cars. Part of what's so unique about the P811 is that the machine is supplied with new ties as it rolls down the line. We don't know if it's by design or just happenstance, but the work train is being pulled with a post-merger set of locomotives. A Santa Fe GP38R leads a Burlington Northern GP39M, rebuilt from and still looking like a GP30. The engineer's job on this work train is quite demanding. It's extremely important that the train be operated at a constant speed. Keep in mind that these locomotives are pulling the P811 down the track as it removes and lays ties. Any problem occurring on the P811 requires the immediate stop of forward motion. Wheels slip as the two diesels creep forward, maintaining a steady pace. Specially designed flat cars carry the new concrete ties to supply the P811 and to store the removed wood ties. The cars are equipped with a track that runs along both sides. Also note the bridge that crosses between the cars. Overhead gantry cranes run a relay back and forth between the flat cars and the P811. In the distance, you can see two of the gantry cranes. They can't pass one another, so each crane covers a certain distance, relaying ties back and forth in their territory. The cranes are designed for the specific task of handling a flat of 22 ties. Here, the first crane deposits a load of wood ties on the flat car. Each pile is stacked just 6 high, so the cranes can pass over them. The operator now grabs a flat of concrete ties to deliver to the second crane. That crane will deliver them to the third crane, which in turn will deliver them to the P811. 2 workmen have been assigned to the rather easy task of removing planks used to separate the flats of new ties. On this project, over 52,000 concrete ties will be laid in curves along a 25-mile stretch of the line. Wood ties will remain in place on the tangent portions of track. The first crane soon returns with a load of old ties and runs right over top the 2 workmen who keep low while this is happening. As a bit of humor, one could say that these guys are sitting down on the job, laying low and getting paid for it. From time to time, the train comes to a complete stop while a problem is resolved on the P811. It's soon moving again, and a view toward the front shows how many ties have already been handled today. The train is serviced overnight, so each morning when the crews begin work, all of the flat cars are loaded with new ties. A close-up shot shows how the cranes roll along the tracks on the flat cars. Gantry crane number 2 arrives with a load of old ties. Notice that each crane operator wears a communications headset so they can keep in contact with one another and the job foreman. As crane number 3 picks up a load of new ties to complete the relay, we get our first view of the actual P811 machine, and the excitement grows as it nears our position. The first portion of the machine has a plow attached, which clears ballast from each end of the ties. This makes room for additional ballast to be removed later on when the old ties are lifted out of the roadbed. A spike puller trolley runs along underneath this first car of the P811 to remove the last of the spikes not taken out by the first machine. All spikes must be removed at this time. Back on the main part of the P811, note 4 things that are happening. New ties on the top platform are being fed into the machine, and old ones are coming out on the bottom platform. On the ground, you can see the additional ballast referred to earlier that's being kicked out from under the P811. The other thing to note is how the rail is being lifted around the machine, which can be seen beginning under the man standing by the green duffel bag. Guides attached to the machine force the rail off the ties. Additional guides continue to force the rail to the outside and around the P811. This shows the resiliency of continuous welded rail. Crane number 3 arrives to feed a load of new ties into the machine and will then leave with a load of old ones to deliver back down the line. It's easy to see how timing is an essential part of this machine's operation. If new ties aren't delivered fast enough, it will run out, or if the old ties aren't removed quick enough, there will be no room to store anymore. As we view the mechanism removing old ties from the roadbed, the thought might occur as to how this huge machine supports itself without there being any rail for it to ride on. A close-up shows just how that is accomplished. A tracked platform crawls along under the P811 to support the weight that would normally ride the rails. As the old ties are lifted from the roadbed, a set of rotating teeth like those found on undercutter machines removes ballast. This creates a trench where the new ties will be dropped in place. With all the moving parts on this machine, the operating crew must constantly be alert. Letting one's mind drift for a moment could easily result in serious injury. To help alleviate this possibility, the men rotate positions often to keep sharp and to rest. Two at a time, the ties are loaded into the mechanism that drops them into place. Once dropped, another part of the machine pushes each tie ahead a few inches to help seat them into the ground. The ties come from the plant with metal guides already in place that automatically gauge the rails. Crew places hard rubber insulator pads in each guide to separate the rail from the concrete ties. These pads absorb the pounding of heavy trains to protect the concrete from wear. Behind the insulator crew, guides on the machine force the rail back into gauge. Now this fellow looks like he has it made, but he's actually performing a very critical job. He makes final adjustments to the guide arms to properly seat the rail onto the ties. A set of wheels on the rear of the P811 are the first to roll over the newly laid ties and help to further seat the rail. This absolutely amazing machine is a marvel to watch. We'll take just a moment to once again view it in operation as it continues up the line at about 1/2 mile per hour. Once the work train is well clear of our location, we get an open view of the newly laid ties. However, this job isn't finished yet, since the rail has not been fastened to the ties. The first thing to happen behind the P811 is for a tamper to work ballast up under the new ties. The tamper straightens up misaligned ties and provides a firm foundation for them to rest on. Behind the tamper comes a machine that will clip the rail to the metal guides on the ties. A total of 4 men ride the machine, 2 on each side. The first 2 place insulators on the bottom edge of the rail, where it comes into contact with the metal guides on the ties. The following men set the rail clips, which will be mashed into place by a hydraulic press located to the rear of the machine. The rail is now locked in place. This completes this portion of the task. To complete the entire job, fresh ballast will be dumped on the roadbed and then tamped and groomed into shape before trains will be permitted to run over the line. We view just some of the many different jobs performed on today's railroads. The industry has come a long way from the days of old when gandy dancers worked the lines. No one can predict with accuracy what new methods lie ahead. But one thing's for certain, America's railroad industry is on a roll, and new technology will continue to find its way to the rails, making working on the railroad a faster, safer, and more cost-effective part of this fascinating business.